Hello. In this video, we're going to learn about XML, which stands for Extensible Markup Language, which is very close to HTML, which stands for Hypertext Markup Language. And in particular, we're going to learn how to use Java, not JavaFX in this video, but just Java to use a library to help us parse and create XML text documents that are easily readable. To start off with, I'd like you to take a look at some code from a very simple website. This website does not do very much, but what we're really interested in is the underlying code. The content of a website is described by the use of things called tags. And a tag is surrounded by a less than and a greater than symbol. So for instance, we have an HTML tag up on the first line. We have a head tag on the second line. And the spacing between tags doesn't matter, although I do like to use indentation to help it be more human readable. But what these tags mean is they give us a way to take our text and arrange it into different sections. So for example, an HTML document, we have an HTML tag and another HTML tag here. And notice the slash in front of HTML here, that indicates this is a closing tag. An HTML tag is separated into two sections, a head section, as indicated by the head tag, and a body section, as indicated by a body tag. And within each one of these tags, you might have more and more nested tags. For example, here we have a title tag. In this case, this is the title that would appear in the top line of your web browser. Within the body, I have two paragraphs, which are indicated by these P tags. First would say hello world, the second would say welcome to my web page. And the great thing about this, again, it's easy for a computer to parse, right, because of the use of tags, but it also remains human readable. That's just a really quick introduction to HTML. The important thing is this concept of using tags to sort data can be used in other contexts other than creating web pages for the internet. For example, here's another file. And this file, instead of indicating the contents of a website, could be used to, for example, indicate the contents of a library. We might get that idea by the fact that we have a library tag here. And this library contains 3 items. It's a very little library. Again, as you might have guessed from the tags, I have one called book, another called book, and one called music. And each book has some information. Each book has a title and an author. Each piece of music has an artist and an album. And so these are some of my personal favorites. But again, it's a way of taking data, of sorting and organizing it. So what we'd like to do is learn how to make documents such as these. And we're going to use a nice little Java library to help us with that. Now, the interesting thing about this example is that these tags are not standard tags at all. I just totally made them up for this example. And that's in the spirit of XML. XML and HTML, well, they have the letters M and L in common. Right, so what do they stand for? XML is extensible or extendable markup language, while HTML is hypertext markup language. Right? The hypertext are the links which bring you from one page to another, thus making the individual pages connected in a sort of web that spans the whole wide world. Right? But XML is just a markup language, a way of marking up using tags some information, but it's extendable or extensible. You can make up your own tags to suit whatever needs that you have. Now, here we're not going to reinvent the wheel. We're going to use a pre-existing library. There's one I particularly like because it's simple and straightforward. It's called XOM, spelled X-O-M, and you can download this for free at xom.nu. The idea is it's just a very simple Java library to work with these kinds of documents. It's so simple, we'll actually end up extending it a little bit in the project we're about to see. Now, depending on the software you're using for your Java development environment, you'll actually have to include the XOM library of functions in some way. From xom.nu, you can actually download a jar file which contains some code which our applications are going to use. And if we're using BlueJ, an R class, one way you can set this up, within your BlueJ project, you can create a folder called +libs, and within that folder, add whatever jar files contain the code you would like your application to load. And whenever a new project is opened, BlueJ automatically looks for a +libs folder and loads all the code in that library. All right, so for our first example, I'd like to show you some code which can generate this XML file that I showed you initially. And so this is in a class I call XML Examples. It imports everything from the XOM library and also some things from standard Java. One of the core classes in the XOM library is something called the element class. And an element you can think of as a pair of opening and closing tags. And the content of those tags, for instance, in the document I showed you, those tags contain the word library. I can create a new element called library, and that'll create that pair of tags for us. Right? And within that tag, we can either put additional tags or some kind of text content. So the XOM library provides two methods called append child, and it's an overloaded method, so you can either put in a string that will give you some text which appears within your tag, or you can add an element which will give you a tag inside a tag. And so append child is useful information. For example, within the book element, I have two more tags, a title tag and an author tag. They appear one after the other like a list, but within the title tag, I've appended a child, this content, this text. And so we'll see all of this happen down here. And so we have our kind of our root. I'm using some terminology from trees, right? We get that a lot when we study data structures. Trees have roots, kind of the main element to which all others are added. And within that, we have nodes, kind of parents and children that are attached to each other. Right? And library is our element, our parent to all other elements. Okay, we're going to create some more elements here. I'm going to first create an element called book that corresponds to the book tag. Then I'll create another tag that says title in between. And within title, I'd like to append a child, and that child is the text content, which says, quote, Lord of the Rings. Then I'm creating a new element. This element, again, is a tag, which contains the word author. And within that author tag, and I'd like to append some content, in this case, the name of the author. And then I need to put together all the different tags. So I take the book1 tag, it's my new element called book, and I'm going to append a child. I'm going to append that title tag that we created. And this creates kind of a nested structure, right? This text is within the title tag because it's appended, and then the title tag lies within or in between the opening and closing book tags. And then after we append the title, we also append the author, and these tags will appear in the order in which they are created. Then once we've finished appending everything we need to the book, we'll append that book tag to the root, which as we saw was the library. And up to that point, we basically have the first 5 lines and the last line of this XML structure setup. Then we can set up a second book element in the same way. Right? We can create our book tag. We create a title tag, which contains this text. Create an author tag, which contains this text. We append the second title and author to this book, and we append that to the root. And I hope some of you are realizing that this is a lot of code, and since we're developers, we're going to try to simplify this code in a little bit. Music, just switch it up. The same structure, just there's different content within the tags. We'll create a music tag, within it an artist and an album. Then once we fill out their content, we append them to the music, and then create the root. Now at this point, we've completed our data structure. We have an element with a series of nested elements, some of which contain even more elements or text content. Now the question is, what are we going to do with this data structure? Well, the most common things are it's used to store data in a structured format. So we'd like to be able to export this data to a text file, or conversely, we'd like to be able to import this data into kind of an element structure that we can then search and query and learn things from. So next, I'm going to show you some examples of how to create a text document. Right? First, actually, before I show you how to create a text document, I'm going to show you how to print out the contents of the tree that we just created, of the element tree. So to do that, we use another XOM class called document, and the document requires the root element. Right? You could put any element you want in here, but it'll only print that element and its descendants or its children elements. But I'd like to see the entire thing echoed to the console. So I'll create a document, then I'll print some things to system out. We're going to print to the console. And a serializer is used to write that data. And so we set up a serializer. This is just the code that we always use, includes formatting information. And the interesting parameters here are set the level of indentation. So every time you have a nested tag within a tag, right, how far over should we indent? I like to use 4 spaces myself. So for instance, book is a tag which is nested within library. Notice there's 1, 2, 3, 4 spaces here. And then title is nested within books. That's indented another 4 spaces from that. Right? Any tags which are adjacent to each other, they're indented by the same amount. And so both title and author are indented by 4 spaces here. And so we set the level of indent. We set how long any particular line can be. So 64 characters is more than enough. And then we run the write method. And that's it. We just write our document. That'll export it to system.out, at the console where we see most things. This could fail, so this is why we're using a try-catch block. If there's any exception, if for some reason the serializer malfunctions and you can't write to system out, now we'll just print an error message and the stack trace. We'll just quit our program. Right? But before we export anything to a file, this is a nice way to preview the contents in the console. Next, I want to show you how to create a file, right? The actual file that we saw. This isn't the Java console. This is a text editor. So how do we create that? Well, first thing we need to do is we need to create a file to contain the contents. So our file will be created, the file we create will be called test.xml. And that's the file name, and we'll initialize a new file with that file name. And we're just going to do something very similar. The serializer in the previous bit of code wrote to system out. The serializer object, which again is a class provided for us by the XOM library, that can also take in a file output stream. And so we're going to create a new file output stream, which points to this file object that we created. And we're going to serialize to that output. Right, so I'll set the indentation level and the max length just like we did before. And again, we're going to write, but this time we're writing into that output stream, which puts output into the file. When we're done, we should always clean up and be sure to close that stream. And again, when we set up the serializer, things could go wrong, so we need to use a try-catch block. And if we get to this point, the system is not exited, we'll get a happy little message saying that we successfully outputted to a file. Finally, the last thing I'd like to show you how to do is how do you read in an XML file and how do you parse it? Writing a parser is somewhat complicated, but fortunately, the XOM library provides a parser for us. So now, this next bit of code is going to read in a file for us. And honestly, what we're going to do is read in the file we just created. In general, if we're doing a Windows-based application, we would get some file from the user that we haven't created ourselves. Okay, so here, I'm gonna create a file or get access to that file with a given file name. Ours was called something like test.xml. And we'll create a document which is initially null. So what we're going to do here is we're going to create a builder object. And I like to think of this more as a parser, but what it does is it's just basically, I guess there's not too much parsing to do since XML is incredibly structured already. But this is going to build a document object for us based on the contents of the XML file. And so all we actually need to do is we'll run the build command on whatever our input file is. And that gives us our new document. And just to make sure that everything goes according to plan, this should print. This is all we really have to do to generate our document. Then in a future video, we'll talk about sorting it. But here, just as a sanity check, I want to make sure that we can print whatever this input file was. And so we're going to go through the serializer. Again, we're going to print to the console the document that we just built from our input file. And again, if something goes wrong, we need to try and catch the exception. And that's it for this class. Let's go ahead and give it a run and see what it looks like. So I right-click. I'll run the main method. Right, let's go all the way up. Right, so this first part is we've built the element, and this is printing the root element. Right, this is just a little code which says the encoding structure which was used for it. The important part is this content here. Right, this is what we saw in our file earlier. This was generated for us by the XOM library. Then we go ahead and we take that content and we store it into a file. Message says our file output was successful. And as you might recall from that code we just wrote, we're going to read the data back in. And since we're really just reading in the data we just wrote, this next bit of text which appears in the console should look exactly like it did before. And sure enough, it does. And so this will take the contents of an XML file, prints out very nicely, but we also have that structured tree-like representation of the contents of that file. So that's how we can create, export, and import XML files. But we're not done quite yet. You might have remembered that some of the code is a little bit unwieldy, right? XOM is a very basic library, and sometimes I want to make something which is a little bit more efficient. So here's one way we could do that. Right, let's take a look at a lot of the tasks that we have to do repeatedly that take up a lot of lines of code. For example, if we create an element, we always have to specify the name of a tag. And sometimes, for instance, the library tag doesn't have any text content, but some of the subtags do have content. So it sure would be nice if there was a constructor for elements which took in both the name of the tag and the name of the content. And another task that we have often, sometimes we want to append more than one child. And so here we want to append 2 different children. Right? And it'd be nice to condense this as much as possible. So there's lots of ways to go about this. The way I'm going to show you is by just creating a class which extends the element class. So it has all the functionality of element plus a little bit more. So I call it XElement. And it's an extension of the element. First constructor, this is just basically doing the same thing that the standard element constructor did. Right? Super here calls the constructor of the parent class, and we just create a normal element object. But also, here's that second constructor I was really interested in. Right? What if we want to make an XElement which has a tag name and we already know the content? I want to do both of these at once. Well, for this constructor, we'll first run the super constructor and then go ahead and append the child. And again, keeping in mind future applications and wanting this to be as flexible as possible, in this case, I'm going to let the content here be, well, any object which can be converted to a string. So perhaps the content is a string, but perhaps the content is a number like an integer or a double. And so whatever that content is, go ahead and convert that to a string and append it. Next, we do a lot of adding. Right, so the add method is really just a rename of the append child method. But you might notice in this method, there's 2 ways you could write this method. I could just do public void add and write the method like so. But you might notice that instead, I'm returning a reference to this object. And this is sometimes called the chaining pattern in programming. So you can run one method after another. I can add one thing, and then I can add another thing. I'll show you an example of that when we see XML examples redone. But this is a different way we could add objects. Or if really you want to add a lot of things at once, another option we have is to use something which is called var args syntax. Sounds a little bit like a pirate, but I'm trying to say var args. So this is a variable number of arguments. In this case, for add all, this will allow me to take any number of element objects as parameters, right? And they will all be packed into an array automatically for us, and that'll be called children. And so add all, right? Basically, that's going to add, well, all these objects one by one. So it's not that bad. I'm going to use a for loop, but this is for each style syntax. Right? So in the what this is going to be an array of children. Right? The child, it'll take out every child object one by one, and then append that to this object. Okay, so again, just some notes. Children is really, think of it as like an element array, or it could be an XElement array as well, since XElement extends element. But that array is created automatically from a comma delimited list. And this for each code, in case you haven't seen this syntax before, it's very useful when you're working with arrays. So this is equivalent to saying for int I equals 0, I less than children dot length, I plus plus. Then we'll say then element child equals children I. And then it goes ahead and does whatever the rest of the code is, right? This append child dot child. Again, this is something that we have to do so often in Java programming, right? Iterating over an array and then doing something with every element of the array. We have this great syntax called a for each loop. So we're just basically appending everything that was passed into this element. And then we return this. All right, so I put it to you that using XElements can make our code slightly more efficient than the default library. And to illustrate, I'm going to go ahead and take the XML examples from the other class and redo those examples. And this is from the XElement class. All right, so this uses XElement class. So similar to before, I'm going to create an element which contains the word library. I'm going to create my XElement, which contains book. And here's our first improvement. Right, my XElement, title 1, right? I create an element, but I can give it both the name of the tag and the content all at the same time. Right, so it's a little bit more efficient. So I create 2 more XElements, title 1 and author 1. And then I use my new add all method to add both of these objects to my book, then add that to the root. Okay, so we saved a couple of lines of code here. And also, as kind of a fun note, I wouldn't actually do this, but you could also do, I could add title to the book, and then I could add something else as well. Right, this is kind of an interesting pattern. It's called, again, the chaining pattern, in that after you finish doing some method on your object, return the object so you can call more methods on it, all on the same line of code. And so this is also possible. But we have add all, so we don't really need to do that. Now, here's an even shorter way we can do this. Right, so we don't have to keep thinking of names for all these intermediate variables. We could just create these new objects anonymously as parameters. Right, so to create my next book in the XML file, I'm going to create a new XElement, a tag containing book, and then I'm going to add all the following XElements. Right, so I'm going to add this one, and then there's a comma. I can put in as many XElements as I want. Right, highly efficient line of code. This line of code makes me very happy. Then we can add that to the root. In fact, I guess you could actually just take this code and put it in here, so you wouldn't even need to create the object book too, but there's a limit to how far I will go for readability. There's another example. Here's how we would create the music tag. This is a music tag, not a book tag. And so we've got our new code right here. And then, again, we are complete. And just like before, this example contains writing the code just so we can make sure that everything works. So let's go ahead and give this code a run. Hopefully it should look exactly the same as the code did before. So running the class XML examples redone. Let's go ahead and look at the terminal window here. And sure enough, and this one we just printed the console, but it illustrates that the new XElement class can be used to produce the same elements as the regular old element class. Right, so this is our introduction to XML. Hopefully, we're going to learn more about some additional applications of XML. Right, in addition to web pages using XML, lots of other applications, as we're going to see, also use this syntax. Thanks for listening.